Then I'll just raise the issue. Are there any, where are you? Do you have questions about how to develop that chart? We are now at the point where you have all the special angles in all four quadrants, and you have what I call the quadrantal angles, namely 0, 90, 180, 270, 360, and you know what happens with the SIGNs when we wander from quadrant to quadrant. Question? I'm probably going to just do it in one big quiz. Yeah, even though it's going to take a little while. Now, but by now you realize if I ask you about that whole chart, that's really what? Very repetitive. Of course, there's good and bad to repetitive, right? You make a mistake and repeat it, ouch, ouch, ouch. You get it right and repeat it, joy, joy, joy. So, I don't know. Yeah, and in fact, I have the quiz ready to go, and I'm about ready to give it to you. And we might as well get to it. I wasn't justified in what I said because it turns out that cofunctions are important too. Cofunctions are sine, cosine, tangent, cotangent, secant, cosecant. But that has all cofunctions have to do with is which axis you reference. Now, I've been telling you all over and over, always go to the x-axis. And I'll tell you why I've been telling you that, because then you can stay with the same function. If you go to the y-axis, you can do that, but then you have to switch functions to the co-function. So anyway, just bottom line is my criticism is not valid. Sure, it would have been made one thing neat, but it would have messed something else up. So it's perfectly logical. Can you see that the bottom part of the page really says the same thing as the top part? Just two different ways of looking at it. Okay. All right, a whole new world is opened up. Now, our chart doubles in size. Because now, you can fill in the other 6 functions. How? By taking reciprocals. Oh, except for one thing. There's some things you can't take the reciprocal of. Yeah, thank you for the bum bum bum. Yeah, we need a little drum roll. See, you can't take the reciprocal of a 0, you know that. And you sure can't take the reciprocal of a UND. I don't even know what a UND is. Well, it's an unknown number. How can you take the reciprocal of something unknown? So, with those 2 exceptions, let's fill this in. And now your table is twice as big. Now, that is, if you memorize this, these 3 new functions, you should now be able to fill the rest of this in. Well, for example, remember, cosecant, CSC, is a reciprocal of the sine. I can't take the reciprocal of 0, so I have to make that a UND. I can take the reciprocal of 1/2. The reciprocal of this is square root of 2 over 1. 2 over the square root of 3. The reciprocal of 1 is 1. Let me know if you don't get what I'm doing. Okay, then the secant is the reciprocal of the cosine. So where am I looking? My eyes are fixed on the cosine line right now, right? I'm up here. The reciprocal of this guy. reciprocal of the tangent. Now here's your first reciprocal of a UND. Well, there is no such thing, but if you think of it in reverse, the reciprocal of a 0 is a UND. The reciprocal of a UND is not a 0, but you can think of it in the other direction. Couple angles missing here, but so here again, not very hard. I didn't really do much new today, did I? Thank you. Sorry to boot you out there. Did we really? Yeah. So Christina, we introduced 3 new functions. These guys are the reciprocal functions, and then all we did is take the top half of the chart and basically reciprocate it. But you had to be aware that you can't take the reciprocal of 0. So we had to make that a UND. And when we had a UND, we had to make the opposite of 0. With that in mind, we just doubled the chart. So here again, good news and bad news. Good news is, if you remember just like 3 new things, this shouldn't be very hard. Bad news is, if you got any of those boxes wrong on the top of the chart, you are not going to get those right on the bottom of the chart. Because when you flip something over that's incorrect, guess what? You're going to get something incorrect. So, you know, really, did we make much of a change? No. Now, this is starting to, here's another one. Is it even more important now that you got the red box right? Oh my. Yeah, not only is the red box projected all the way to the right, along with the correct SIGNs, but now it's mirrored downward. So that's, just repeat one last time, it's both wonderful and it could be terrible. Same triangles. So really, the bottom half of that, I don't use triangles for at all. That is, if I really have my triangles nailed down and I have my SIGNs right and really trust myself, then I should be able to do that blue part just by looking at the black part on the top. Does that make sense? Okay. So, that's the first step today. That's really it. I mean, this chart, I could go further with this, but we don't have time in this course. If this was just a trig course, I would show you some more cool things. Just so you know, you can find, if you can find the sine of an angle, then you can of 2 different angles, and you can find the sine of the sum of them. Not just by adding them together, but there's a law that allows you to do that. Well, therefore, now not only 30, 45, and 60 work, but any sum of those. So 75 works because it's 30 plus 45. And all kinds, and then there's a law for finding the sine and cosine and tangent of a half angle. And so now every angle we know, 30, 45, and 60, can be cut in half. And now without a calculator, you can find the tangent of 22.5 degrees. And so some of you are wondering, I know you asked the question, are those the only angles we're going to do? What about the angles in between? Actually, there's an infinite number of more you can do without a calculator. But we do not have, alas, infinite time for this course. So I have to cut it off. In fact, it's terribly finite. Sometimes I weep about that. Almost, because I honestly believe trig should be a separate course like it used to be here, because there's some really cool things that should be explored. But anyway, we can't do it, so I've already told you this. Now, I probably should have written it with the thetas in there. You know, this is actually more accurate than the other one. Now, I want to show you something. Using the unit circle, I have written in, does this look familiar that the cosine is the horizontal leg and the sine is the vertical leg? And you know what the hypotenuse is. It's a unit circle, so doesn't the hypotenuse have to be 1? What happens when you do the Pythagorean theorem on that? Well, I did it on here. And do you see how one leg squared, the cosine of theta squared, plus the other leg squared should equal the hypotenuse squared. Right? That should happen with every right triangle. Now, are you familiar with this notation? Cosine theta squared can be written this way. How many of you have seen this type of notation before? Okay. I'm sorry, but it's another shortcut that mathematicians take. This means exactly the same as that. So anyway, and sine theta squared can be written as sine squared theta. Okay? And what you come up with right here is a very important, what we call identity. And in fact, it shouldn't surprise you, it is called a Pythagorean identity. It's called a Pythagorean identity because it obviously comes from the Pythagorean theorem, because it comes from a right triangle. And so it's the first identity of 3 that I was going to give you today. In that top box, there it is again. Cosine squared theta plus sine squared theta always, always, always equals 1. So in other words, you could pick your angle, 38.9 degrees. And I guarantee you that if you take the cosine of that angle and then square it, and then take the sine of that angle and square it, and add those two up, I guarantee you the answer will be 1. That's what we mean by an identity. An identity means this will always work no matter what theta is. Okay? I wish I had time to show you these, but there are 2 other Pythagorean theorems. They come from a right triangle again. The tangent squared of an angle plus 1 will always equal the secant squared of an angle. And in box number 3, the cotangent squared of an angle plus 1 will always equal the cosecant squared. We'll talk a little bit more about this next time, but I do have an assignment for you. I showed it. Some of you saw it. It was up there. We can now do that whole 9.3 assignment. I kept telling you, pick this, pick that, don't do this, don't do that. Now you can do whatever odds from 1 to 97 if you haven't already done. Okay, you may have done some of those already.